All right, let's crush another chemistry question. This one says, for each of the following molecules, draw a Lewis structure, describe the molecular geometry and polarity, and give the hybridization on the central atom. All right, so valence electrons are pretty important to this type of stuff, drawing Lewis structures. So let's figure out how many valence electrons each of these elements has. So sulfur is going to have 6 valence electrons. Chlorine is going to have 7. Nitrogen has 5. And oxygen has 6. So given that information, let's try to draw the geometry of what's happening here. So I'm seeing SCl2. Since we have 2 chlorines, I'm going to assume the S is the central atom, and then we're just going to have 2 chlorines off of that. So initially, just a rudimentary drawing, I'm going to assume that our molecule looks something like this. Now let's consider all of the electrons that are going into this. So chlorine has 7 valence electrons. So that means we're going to draw dots for the electrons all around the chlorine. So we've got a pair here, a pair here, a pair here, and then we'd have 1 extra electron. The 7th electron could go into the bond and bond with the sulfur. So that actually looks pretty good to start. You have 3 electron pairs and then 1 electron in the bond from the chlorine. Let's see if that works for the sulfur. We need all of the electrons to be paired off, so hopefully this works out. Sulfur has 6 electrons, and since we have 2 bonds coming out of it, that would leave 4 electrons left over because it has 1 electron going into each bond. So this adds up correctly. If we look at our hybridization chart, you can see that a situation like this, where we have a central atom with 2 lone pairs and then 2 atoms coming off of it, would give us a bent shape. So it actually wouldn't be linear like this. So I'm going to redraw this entire compound with a bent shape and consider that both of the electron pairs would kind of be stacked on top of each other. So initially I drew that kind of rudimentary drawing just to kind of get a feel for how the electrons are working out. And then once I know how many electron pairs there are, I can go to my hybridization shapes and figure out what's actually going on. So now that I know that this is bent because of the hybridization, I can tell that there's going to be something like this going on. And then our 2 electron pairs are going to be up here on the sulfur. And since this is bent, this is going to be a polar molecule. And the dipole moment is going to be going in this direction. So basically, this end of the molecule is going to be acting as a negative charge, and this would be acting as a positive. That's what this arrow means, because there are more electrons located in the bottom of the atom than the top. And then finally, the hybridization of this bent molecule with 2 lone pairs, which we can grab from our hybridization chart, is sp3. So in summary, this thing is bent, polar, and sp3. Next, let's address our NO2. So similarly, we can draw like sort of just a simple diagram of what's going on. We've got 2 oxygens and a nitrogen, so they're telling us that N is the central atom. I think that's relatively obvious given the structure of the compound, because if you have 2 of the same atom and 1 of another atom, typically the 2 same atoms are going to be branching from the central atom. So you got something that looks like this. And then oxygen has 6 electrons, which is a little weird because we've got 2 bonds. So like ideally, we would make a double bond for oxygen and then have 2 electron pairs. The problem is that nitrogen has 5 electrons, 5 valence electrons, right? We found that out earlier. So if we have 4 bonds, we just have 1 electron left over, which isn't good. So this is an interesting molecule because this doesn't balance very well. So what this molecule does is it'll have 2 different kind of setups. It's only going to have 1 double bond at a time, but it could be on either oxygen. And that allows for us to have an electron pair on the nitrogen, and the nitrogen only has 3 bonds coming out of it, which means that its 5 electrons can form this final pair, because 3 of its electrons are tied up in bonds, and the last 2 will form a lone pair on the nitrogen. So what will end up happening is whichever oxygen has the single bond will need to make another lone pair somehow. We say that it has like a negative charge because we're going to need an extra electron to pair all of these lone pairs on the oxygen. So this one on the right is going to have the double bond on the right. We'll have these two separate situations here, where one of these is the mirror image of the other one, but both have this kind of extra electron, right? There shouldn't be this many electrons in this picture. So we have to put a negative charge on the molecule because we're adding an electron in order to pair off all the electrons on the oxygens. But this is the situation that we end up with. And then again, if we go to our hybridization chart, we've got this structure with a lone pair on it, which is going to lead us to having a bent molecule. And bent molecules are going to be polar. So we've got these two structures. Both of them will be bent and polar. We've got two atoms coming off the central atom and one lone pair, so that's sp2 hybridization. And that's all the information they were looking for.